Let us prove by the method of induction that 10 to the power n plus 3 times 4 to the power n plus 2 plus 5 is divisible by 9. So first step, we will frame the statement. Let Pn be the statement 10 to the power n plus 3 times 4 to the power n plus 2 plus 5 is divisible by 9, comma n is a natural number. N is a natural number. So at this stage, we are just saying that this is a statement. We don't know whether it is true or false, but we only know that this is just a statement. Now, a mathematical induction involves three components. First, a statement, then a starting point, and then a cycle. So we define, we know what is P1 now. Therefore, P1 is the statement. P1 is the statement. We just write n equal to 1. So 10 to the power 1 plus 3 times 4 to the power 3, 1 plus 2 is 3, plus 5 is divisible by 9. That is 10 to the power 1 is 10, 4 cube is 16 times 64, 64 times 3 is 192 plus 5 equal to 207 is divisible by 9, is divisible by 9. Is this correct? Absolutely. So you can say that P1 is true. That is, when I write n equal to 1, we can find that the given statement is true. So starting point is true. So we can start the induction step, but further we need to prove it, that it is true for every n. To prove it, we need to assume something. So we need to get some kind of cycle. So we assume that Pn is true for n equal to k. Let us assume that Pn is true for some n equal to k. We are assuming it to be true for at least one n equal to k. We saw that if we take k equal to 1, that's true. So we are making reasonable assumption. We are not saying that it's true for every n, but we are saying that it is true for n equal to k. That is 10 to the power k plus 3 times 4 to the power k plus 2 plus 5. So we are writing instead of nk. So 10 to the power k plus 3 times 4 to the power k plus 2 plus 5 is divisible by 9. Now what we want to show is that if it is true for n equal to k, then it has to be true for n equal to k plus 1. Let's do it. But 10 to the power k plus 1 plus 3 times, we are replacing n by k plus 1. We are replacing n by k plus 1. So 10 to the power k plus 1 plus 3 times 4 to the power n plus 2. So k plus 1 plus 2 plus 5. Once again, what we did is we replaced n by k plus 1. So 10 to the power k plus 1. We replaced n by k plus 1. So 4 to the power k plus 1 plus 2 plus 5 we copy as it is. That's good. Somehow we want to use that criteria, that or assumption that 10 to the power k plus 3 times 4 to the power k plus 2 plus 5 is divisible by 9. Now 10 to the power k plus 1 can be written as 10 times 10 to the power k. Okay, so far so good. That looks similar. What about this one? This can be written as 3 times 4 to the power k plus 2 plus 5 we copy as it is. Now we want it to be divisible by 9, so 10 can be written as 9 plus 1. 10 can be written as 9 plus 1. Okay, the rest we copy as it is. Again, what about this one? 12 can be written as 3 plus 9. 12 can be written as 3 plus 9. Times, we copy as it is. 4 to the power k plus 2, we copy as it is. Plus 5, we copy as it is. So this can be written as 9 times 10 to the power k, plus 10 to the power k, let me write below, plus 9 times 10 to the power k plus 2, plus 3 times 4 to the power k plus 2, plus 5. Well, by our assumption, 10 to the power k plus 3 times 4 to the power k plus 2 plus 5 is divisible by 9. By our induction assumption, this is divisible by 9. Or in other words, it's just a multiple of 9. What about this one? Sorry. Oh, I made a mistake. 9 times, definitely this is divisible by 9. I should write 5 here. This definitely it is a multiple of 9, so this is divisible by 9. What about this one? By our induction assumption, 10 to the power k plus 3 times 4 to the power k plus 2 plus 5 is again divisible by 9. So what we see is that both the quantities are multiple of 9. So sum of the multiple of 9 is again multiple of 9. A multiple of 9. A multiple of 9. This quantity, it is simply a multiple of 9. We can see it clearly. This one is multiple of 9 because of our induction assumption that we are assuming that Pn is true for n equal to k. That is 10 to the power k plus 3 times 4 to the power k plus 2 plus 5 is divisible by 9. So what do we get? We find that 10 to the power k plus 1 plus 3 times 4 to the power k plus 1 plus 2 plus 5 is a multiple of 9 or is divisible by 9. So we find that pk plus 1 is true. Pk plus 1 is true whenever pk is true. But we already saw that P1 is true. So from this, if we take k equal to 1, we find that P2 is true. Again, if we take k equal to 2, then we find that P3 is true. Again, if I take k equal to 3, then we find that P4 is true. So we can say that Pn is true for every n. So by principle of mathematical induction, once again by the principle of mathematical induction, Pn is true for every n. That is 10 to the power n plus 3 times 4 to the power n plus 2 plus 5 is divisible by 9 for n equal to 1 that we have already seen. We have just shown, rather we saw that P1 is true. So for n equal to 1 we saw it to be true. Then we take k equal to 1 and we got it P2 to be true. Then we take k equal to 2, P3 is true, and so on. So for every n it's true. 10 to the power n plus 3 times 4 to the power n plus 2 plus 5 is divisible by 9 for every n.